Okay, so in this clip I'm going to talk to you about what we actually use the derivative function for and how we use it. I think I mentioned it before, but I just want to go into a bit more detail. So what is the purpose of the derivative function? Right, so you've obviously seen how to work out the derivative function, and later on I'll show you an easy method of doing it rather than using the first principles, which takes a little bit of time to do. Right, let's look at this graph here. This blue graph here is the function f of x equals x cubed. Okay, so for example, if you take the number 2 and cube it, you get 8, and that's this point here. This coordinate is 2 across and 8 up. Okay, oops, 2 across and 8 up. Right, that's that coordinate there. And if you take this point here, number 3, and cube that, you get 27. So that point there, if I move it along, would be, oh, it's gone off the screen, it's 27 up. Now, the thing is this. What if I wanted to work out the gradient of this tangent line, this red line now, that touches this original point here at 2? So what is the gradient of that red line there? Okay, what's the gradient at exactly that coordinate there, 2 across and 8 up? Well, you know, what's the gradient there? Computer's worked it out for me. It's telling me it's 12, but the derivative function, the computer's actually using the derivative function to work that out. I think it is anyway. But the derivative function tells you what the gradient is at that particular point. So the derivative function, okay, for this particular function is this. It's f dash of x. I should really make smaller apostrophes there. That's far too big. It looks like a number 1. It should be like an apostrophe. But the derivative function for this is 3x squared. Okay, 3x squared. So if I wanted to work out what the gradient is at this coordinate on my blue graph here, I would do f dash of 2. Okay, so I'd substitute 2 into this function. So I'd do 3 times 2 squared, or 3 times, well, 2 squared is 4, so 3 times 4 is 12. Okay, so, and that's the value we've got here. The gradient at this particular value, at this coordinate, is 12. Now, what if I wanted to work out the gradient at, let me delete this. What if I wanted to work out the gradient at, let me delete that. Can I delete it? Let's see, delete, no, alright. Select that, delete, okay, it's not letting me do it, I'll have to do it somewhere else. Alright, I want to work out the gradient at minus 1. Okay, so minus 1, let me move my, oops, minus 1. Okay, so let me move the point to minus 1. Okay, minus 1 would be about, ooh, can I zoom in? No. There we go, minus 1, there it is. Okay, minus 1, so we should get a value of 3. But does the derivative function give us 3 as well? So let's work out f dash of minus 1. Oh, f dash of minus 1. So that'll be 3 times minus 1. Oh, it's really messing this up. 3 times minus 1 squared. Okay, so, well, minus 1 squared is just 1, and 3 times 1 is 3. Okay, now, it'll work for no matter what function you have. So, for example, if I change this, let me change this function to something along the lines of x to the power of 4. Okay, so x to the power of 4 now. First of all, can I delete this? Will it let me delete that? Yes, it will. Alright, so it will let me delete it. Okay, so delete, please. No. Delete that. No. Alright, select again. Delete. No. There we go. Right, delete. Alright, delete. There we go. Right, okay. So this function, okay, this graph at the moment is f of x equals x to the power of 4. Okay, and right, its derivative function is f dash of x. Its derivative function is 4x cubed. Okay, so by first principles you'll get that its derivative function is 4x cubed. Okay, just trust me on that. I'll show you a way to work this out quickly. Right, now let's do the same process again. Let's say I wanted to work out the gradient at this coordinate, which is 2, and that would be 16 up. Okay, 2 across and 16 up, this red dot here. So what's the gradient at x equals 2? Okay, so x equals 2. What's the gradient of that coordinate there? At that coordinate, what's the gradient red lines, I would do f dash of 2. Okay, and work that out. So I'll do 4 times 2 cubed. Okay, so 2 cubed is 8, and 4 times 8 is 32. And what does the computer say? Well, the gradient at that point is 32. So that's the purpose of this derivative function. It tells you the gradient at anywhere on the graph. And all you have to do is substitute in the x value of that particular point. So if I want to work it out at, let's say, -3, okay, -3, I would just do f dash of -3, because that's the x value here, -3, and do 4 times -3 cubed. Okay, and so that'd be 4 times -27. Okay, and 4 times -27 is -108. So there you go. That's the gradient there at -3. Okay, even though we can't see the coordinate, the computer's telling us is -108. So that's the purpose of the derivative function. It just tells you the gradient any way you want. But each function has a unique derivative function. Okay? Oops, that's the telephone, so I'm going to stop there.